Hello, everyone. So, next up we have Richard Brown, and he's going to resurrect some dinosaurs for us. And let's see what can go wrong with that. Thank you.
Thank you very much. Yeah, so I'm here from the OpenSUSE project to talk about how containerized applications, so things like Snappy, Flatpak, etc., like resurrecting dinosaurs, Jurassic Park, eating our users, how it's all going to be terrible. So, yeah, those who can't remember the past are doomed to repeat it. So before I get into the history lesson, I'm going to talk a little bit about my history. I've been working in Linux now for, let's say 12 years, maybe even a little bit longer, mostly contributing to the OpenSUSE project, QA, distribution building, package building. So I'm a real distro guy, really interested in dealing with all of these upstream projects, how to then package that software and then redistribute it to users, traditionally in the form of a distribution in OpenSUSE. And so I have kind of been looking at this problem from very much that perspective. Before that, or alongside that, I have also been working as a system administrator. So I've been actually dealing on the hard end of things with users in the real world, dealing with software and dealing with operating systems other than the wonderful ones that work in open source. So starting at the very beginning, I never thought I'd be presenting at FOSDEM and having an opening slide of a Windows 95 architecture diagram. But this is the place to start with, really. Back in Windows 95, Windows 3.1, the traditional dependency problem is best exemplified by DLL hell. Windows was trying to solve all these wonderful dependency problems, and their solution was pretty much, okay, let's have these things called DLLs, and let's shove all these libraries and dump them in C Windows or C Windows system, and every application will just consume them from there. And everything will be wonderful. But of course, it's Windows, so it wasn't. It's even down to absolutely nobody, not even Microsoft, taking care of any kind of ABI backwards compatibility. Every single update, either from an application or from the system, goes and touches those DLLs, and then every application that required on it all end up magically breaking. Even if you had people who took care of that and dealt with that and actually had certain runtimes and libraries, well maintained and patched carefully and reservedly, you still had nonsense like the global class IDs. So a single application ends up stealing the resources from another. If any program wanted to create an instance of that class, it just always broke. It was a mess. It was a nightmare. And as a developer, working with that stuff, in real terms, it was a nightmare to work with. Every single application had to be developed with every single combination of every single set of libraries that every user might have, and whichever version combination they might have, and then devved that way and tested that way. And then, of course, you need to do an upgrade to your application, so your patch, you have to then retest everything. And then, of course, your various upstream and other projects are changing their DLLs, and you have to repatch all of that. And then even if you did everything perfectly, you still end up crying because it still ended up breaking. And then Windows 2000 came along, and Microsoft claimed they fixed it. And in many ways, they did. It came along, and they said, okay, we realize this is a mess. We're going to stop putting all of our shared libraries in one big dumping ground in the system, in the root file system, in C Windows or C Windows system. And we've got this wonderful thing called side-by-side assembly, which is basically containerization. I mean, obviously with lack of sandboxing, but generally speaking, it completely changed how you practically delivered applications on a Windows file system, on a Windows system. Then all the developer had to do was take their exe and the DLLs that they cared about, and they deliver them in an application folder on the user's system. And Windows would give it a nice separate memory space, load up those DLLs only in that memory space, private to that application. So you didn't have to worry about what the system DLLs were going to do or mess around with that. If you were relying on the system DLLs, you could be way more certain that no third party was going to go messing around and breaking them on your users' machines, because Windows was now protecting every single system DLL with their WSFP or WFP. And for those handling the whole transition between 95 and 2000, they even had this wonderful tool, DUPS. So you could take a nasty old school application with everything scattered all over the place and run DUPS against it. It'll figure out where all those DLL's hooks are, and then you could just bundle all of that into your application folder and migrate everything along, and everything was happy and everything was wonderful. And you didn't even have to do it necessarily with a Windows 32 application. I mean, you know, they had runtimes in there for POSIX, runtimes in there for OS2. I don't know anyone who ever really used them in anger, but you know, they were there. This is the Windows 2000 diagram. So the problem was solved, right? Nonsense. This is Microsoft we're talking about. It was and is and remains an absolute security nightmare. For me, you know, how many exploits are out there that are some random security DLL sitting in some random application folder that's security relevant, that everybody is having a wonderful time exploiting because so-and-so hasn't updated that DLL in their application. It's constantly happening. And it's happening because also there is no centralized way of updating these applications. So every single Windows application developer then has to worry about, okay, how are we going we've got this security issue, we fixed this DLL, or we fixed our own application. How do we then deliver that to our users? Oh, fine, we'll just make an updater. And then you end up with the Adobe updater and Steam and blah and blah and blah. One issue that doesn't get talked about a lot, but especially in the open source side of things, I think needs far more light spent on it as well, is when you're bundling these libraries, do the licenses actually permit that use? I mean, how many GPL cases do we have of some license just bundled in with application because nobody realized actually that can't be thrown away in that? And this is something that happened more and more often in the Windows world. Of course, it wasn't terrible. Storage vendors love it because disks ended up needing to be used more and more and more because you're putting on a whole bunch of DLLs on the system. But you know, they're the only people who are happy, and you know, I guess people like spending money on more hard disks. Meanwhile, about the same time, in Linux land, we were looking on smugly because we thought we'd already fixed this, kind of. And we'd fixed it because we delivered our software in distributions. And I could talk about all the technical details of which distribution's better and blah, blah, blah. But purely from sort of a philosophical and organizational perspective, every distribution dealt with these issues and actually resolved them just by doing the work they were doing, regardless of their technical choices of package manager and build tool and other such things. Because any responsible distribution, at least, had a care about the security of the software they were delivering to their users. They have security teams. They're auditing the packages they're putting in their distribution. They're monitoring CVEs for the packages they're putting in their distribution. They're rolling out security updates when it goes wrong. In the case of enterprise or commercially linked distributions, you know, you're also likely to have them on the embargoed security lists and therefore getting information about those CVEs before they end up being public. So you've got a chance of at least getting an update out on the day of the announcement. Broader than that, just not worrying about the security side of things, you've got package maintainers who are, you know, they're out in the community wanting to package their software, keeping it updated, putting it in the distribution. So the whole how do we maintain this stuff is partly handled by these maintainers doing it just because they want to run their software on their distribution of choice. And of course, like I said, any responsible distribution as well also has a legal team looking at their packages, making sure that the licenses of the software that they're delivering are compatible with each other, so you're not delivering it in a way that is, you know, invalid with the desires or the requirements of the developer in question, and just, you know, generally compliant. You're not out, you know, awfully breaking laws by bundling stuff in that breaks licenses. So even though we're kind of doing the Windows 3.1 dumping everything in one shared bundle and generally living with shared libraries, things aren't too bad. And when we're talking about containerization and containerized tools like Flatpak and Snappy, you know, everyone's talking about, oh, let's kill off shared libraries. That's just, you know, it's a mess. You know, Disk space doesn't matter now anyway, everyone's got bigger disks. But when you start looking at the real work of maintaining everything, shared libraries have another benefit. It's not just about the disk space. Distributing fewer libraries means you've got less work worrying about the security implications. You've got one set of libraries to worry about auditing, one set of libraries to worry about patching, less manpower to maintain it, and it's easy to view that legal compliance, especially when, despite everybody's best efforts, projects love changing their licenses. And there is nothing worse than one version of a project being on one license and then changing to another and figuring out, okay, can we ship both? Are they compatible? We've seen that before where projects ended up actually, we have to move because their license isn't actually compatible with their old one. So shared libraries do solve a lot of those issues by at least giving you one integrated base once you've done the work to actually put that base together. So, mission accomplished? Well, no. The traditional distribution model also has its flaws. And these are the flaws which containerized apps really sell promises trying to fix. Improving the compatibility so developers don't have to rewrite their application for all these different chosen bases of the distribution. Obviously, portability also, so you can just do it once and then have it work everywhere. And distributions typically like to do that work at a certain cadence. And that cadence is unlikely to actually match the application developer's cadence, so therefore the issue of pace of change comes up. A new upstream release has happened, and no distribution is shipping that new version because their release schedule says they'll do it in 8 months or whatever. But the reason they do that is because they want to make sure it works, so there we are. Like I said, a little bit like the Windows 3.1 situation. The compatibility problem the containerized apps are trying to solve really boils down to these simple points. We have lots of distributions, maybe too many of them, with many different libraries, different apps, and different modifications in there. The applications themselves require different libraries, and application developers don't care, and they don't want to care, and they're never going to want to care. They just want to build something that works and push it out there, which is fine. But we've solved this problem in the distribution world already. We have maintainers who deal with all that work. It's not upstream packages putting stuff in distributions most of the time. It's distribution packages figuring out what crazy stuff upstream have done and then distributing it in the distribution. And it works wonderfully when it comes to free and open source license applications. Obviously, proprietary applications, whole different story. On the portability side of things, much the same story, much the same problem. If you're doing all of this work to get the thing working, you only want to do it once. You don't want to have to repeat this 3 times, 4 times, 5 times. And with a very diverse distribution ecosystem, having a nice application that built once and runs everywhere definitely has a certain appeal. But again, does it really matter if somebody's rebuilding it anyway? And then the pace of change problem, like I say, distributions generally have fixed release schedules. And those release schedules generally mean the package versions are frozen in there. Any changes are very reluctant if they are going to be in there. So that holds back new versions, new innovations, new things projects have released from users. That's a bad thing. Rolling distributions are becoming more and more of a trend. In the case of OpenSUSE, we're now doing Tumbleweed as one of our main distributions, and this totally solves that problem. In fact, in many cases, we're now not only keeping pace with upstream projects, in some cases we sometimes outpace it and then have to actually slow things down so we're not shipping their next release before they are. Because it's all in Git, so we just plug our build service into Git and everything's fine and wonderful. Kind of. But that's the distro side of things. Containerized applications want to solve these same problems. And when I'm talking about this, I'm talking really about AppImage, Flatpak, and Snappy. Of course, AppImage started in 2003, Flatpak 2013, and Snappy. So, Flatpak have been doing this for AppImage have been doing this for a very long time. I'm not going to go into the ins and outs of you know, how they all individually work or compare them. I'm talking in general terms because these issues are shared across all of them. So, you know, generally speaking, they produce a bundle, be it a tarball or some other way of packaging things up, containing an application and all the dependencies, all of the libraries that it requires. And then they run it in some kind of container or chroot or sandbox. And they make huge promises. These are all ripped straight from their website, straight from their documentation. You know, all the compatibility problems are solved. You just put everything in there, everything's going to work fine. You know, the portability problems are solved. You just put everything there, you can run it on every distribution. Everything's absolutely fine and wonderful. Pace of change, well, you're the one doing it. You're doing the upstream source, you then can do your app image or Flatpak, everything's fine, and it's just going to work. Everything's perfect. And then you get architecture diagrams like this, or like this one from Flatpak. And actually, it's a bit too fuzzy, so I'll stick with this one. What you end up with these tool sets actually doing is taking the application, the set of dependencies, which in the case of Snappy and Flatpak actually include frameworks or runtimes where there's effectively pre-curated bundles of these applications all sitting there. And then below that, there's just the operating system, and you don't have to worry about that. You know, in the case of Snappy, it's, you know, they're always going to say Ubuntu. I quite like Flatpak because they just say an operating system, which is, you know, if you're going to do this, that's how it should be. The problem is, you're making assumptions about what is actually below that line. Soon, you know, you've taken the dependency problem of, okay, my application needed this library, and now it's my application and all of its dependencies need this version of glibc, or this kernel, or whatever. And no one's quite defined where that line is yet. And there's no common base. Every distribution is different. Even Debian distributions in that family are different. RPM distributions in that family are different. We package things in different ways because we've solved these problems differently in our own environments over the years. So sooner or later, as you start crossing that line between the containerized application and its runtimes and whatever it's getting from the base system, it's going to start breaking. And like I said, AppImage have been doing this since 2003, and they know this problem. They don't lie about this. They don't do graphs like this. Instead, in their documentation, they outright say that the only way you can build a portable image with AppImage is decide which distributions you're targeting, and then look at every dependency you need that's not in any of those and put them all in there. It'll work, but that's a huge amount of work. But that's what you have to do to actually avoid this issue. We're seeing this in OpenSUSE with like Steam, which doesn't quite fit into this model, but you know, Steam is effectively delivered on Linux as a Ubuntu runtime with Steam running on top, so you know, kind of following the same model. Again, that runtime makes assumptions. As soon as we change something in our base system that isn't compatible with what they're expecting from their Ubuntu runtime's expecting, it all breaks. You need to worry about the dependencies. You've just shifted the problem from higher up the stack to lower down the stack. So if you really want to make a portable application, you have to put in every single dependency you might need. If not, expect crashes. Your users will not be able to use your application. So what's the point? Well, like I said, in the case of Flatpak and Snappy, they're trying to mitigate this problem by doing runtime. So at least you say, with Flatpak, you have like the GNOME runtime in there. You effectively have all of the libraries, all of the dependencies to do a GNOME application sitting in that runtime. So as a developer, you can at least target that runtime, know that's going to be there, generally hope that everything further down the stack is sane and okay, and just get on and do the work. And it does mitigate the problem, but at the same time, you've generated a whole other one, which I'll talk about in a minute. And the responsibility of that kind of middle distro becomes really hard to do their job right. They have to then make sure that runtime is keeping up to date with everything, that runtime is secure, that runtime is all patched. And those answers are something which is still in a very gestative state at the moment. I'm not sure about the real solution, But looking at it from a distro perspective, way back when we had this concept of a Linux standard base of, a common Linux that every developer could just assume is underneath there. Of course, that was a pretty hard and pretty impossible agreement to make. But now, with these applications, with containerization becoming more, maybe it's time to revisit that idea. Because, like I say, the dependency problem gets shifted around by these technologies. Maybe collectively, the distributions should be able to get around the table and find out, okay, here's the new line. Here's where we're going to tell every container developer, we'll worry about this and we'll do this in a roughly standard kind of way, and then work on from there. So, maybe we need a new LSB that actually works. So the reality of the big promises of containerized applications is, well, they're not going to be compatible. Unless you're going to worry about every single dependency, it's not going to necessarily work. They're not going to be portable unless you do every dependency for every distro which you might possibly want to have a user running it on. The pace of change thing, that's solved. It does solve that real problem. But you can't say it's just going to work now. You can maybe say it's going to work on certain distributions, like AppImage suggests you should be saying, but you can't guarantee it's going to work everywhere. And this is just like you had in Windows 2000. We're repeating history with this. Because even if you say this is still worth it and still worth going ahead with these technologies and still doing that way, we're going to end up with security relevant libraries in all of these containers. You're bundling all those dependencies in there to make this work. Who's going to be making sure they're valid? Who's going to be making sure they're secure? Who's going to be patching them when they're in there? How are you going to patch them? Okay, Snappy does have the concept of app stores, but how do you guarantee then that everybody with your snap from every app store gets the right version at the right time? I mean, that's going to be a bit of a mess. How do you handle the package management for Flatpak? With AppImage, they don't even have a rough answer for that now, as far as I can tell. It's just download a new bundle from the website. They're going to have people creating updated apps for this thing. Who's doing the legal review for all of these these dependencies in these bundles? Who's making sure that they all can be distributed at the same time? Especially when you look at certain licenses where the runtime aspect of the license is fine. We can plug into anything and everything's fine, but we do care about how you distribute or redistribute the software. That's where our lawyers inside OpenSUSE really spend a lot of time and effort paying attention to, making sure that we can legally redistribute this software. Who's going to be doing that for your application development, for these containerized applications? If you've got thousands of people using these tools to build all these applications, do you need thousands more lawyers? But of course, it's not all bad. Storage vendors are going to be even happier because you're going to be buying even bigger disks. These tools are really powerful. They are really cool. But with great power comes great responsibilities. And I think with these tools like Snappack and Flatpak and Snappy, the only real solution, if you're using them, is to start thinking like a distribution developer and maintainer. You're going to have to deal with the same responsibilities that we deal with in the distribution world. You're going to have to consider how you bundle this, how you maintain it, what is your update cadence, how do you deal with the update cadence of all your dependencies? Do you therefore end up doing regular releases every few months? You bundle them into your application. Where do you bundle them? Where do you draw that line? Which of course is something, like I say, the new base might be an answer for. You're still going to have to develop and test everything on every possible distro. Unless you bundle every dependency that you need from anywhere, you're still going to have this problem of making sure that does your bundle work on these distros. You're still going to have to, if you're doing some kind of regular update cadence, you're going to have to worry about all your patches and making sure they all work again. And I suspect you're going to end up crying because it's all going to break anyway. And you're going to have to worry about the security side of things. You're going to have to worry about auditing not just your code, but all of the code of every dependency you've chosen to put in your bundle. And you're going to have to monitor the CVEs for those bundles. You're going to have to audit those libraries. And as you heard in the previous talk, you can't necessarily assume sandboxing is going to be enough. Sandboxing is a great safety net that some of these tools do recommend and do use, but it should be thought of as a safety net, not as a solution to these problems. Security is something that should be integrated by design, and then you have a safety net to cover your ass when it screws up. You're going to have a nice, fast way of getting that update through and out to users very, very quickly, and in a relatively efficient way. And of course, that gets tricky. If you've got all these big bundles full of all of these big libraries many, many times over, and let's just imagine that everybody's got a copy of OpenSSL inside their container. How many times are you going to have to download a whole new bundle, on the same machine? Does a user really want to download 40 gig just because we fixed one issue in one lib that happened to be in 40 different applications? It's going to be painful. And yeah, legal side of things, we're going to have to, anyone using these tools is going to have to review the licenses, going to have to make sure that what they're doing is above board, is compatible, and is compliant with the licenses, that not just the original software is included, but all of the dependencies and libraries are involved. I think distributions can and should be part of this solution. I've been up here now, I've been ranting about why all this technology is bad. I actually like this idea. I like the idea of containerized applications. Because from a distribution point of view, I'm going to have less work. If application developers are doing all of this stuff and worrying about all of this stuff and distributing it, I have less packages to worry about in my distribution. I have less responsibility for those packages. I actually want to encourage this idea because I think it is, if done moderately and sensibly, a more sustainable model than everything being centralized on a distribution. But I just want to make sure our users don't get eaten by broken, dangerous apps in the process. So like I said, I think distributions should be coming together, thinking about a common base for where that line is between the underlying distribution side of things and all of the libraries on top. Otherwise, the portability promise is never going to be achievable. Unless that exists, I don't really see everybody bundling everything in every application. That will just be crazy. And I also think this, with some of these tools, there's kind of a tendency to kind of paint the distributions as, this is the evil that the tool is expected to get rid of. Oh, you don't have to worry about sending your package submission anymore. You don't have to worry about this crazy review. You don't have to worry about that. Distributions have these tools and these processes and these techniques because we've been dealing with these problems in the real world for years. So actually looking at our tools, looking at how, for example, the OpenSUSE build service works, looking at how OpenQA works, has a surprising relevance to these technologies. And you don't have to necessarily reinvent every wheel. The solution might be a simple case of patching in a new package format into those tools to then handle Flappy or did it again, Snappy or Flatpak. One last final thing for this. I'm not sure, despite me liking the idea and thinking, I like the idea of less work, I'm not necessarily sure it's actually that a sensible way of going along. Because it comes from this concept of, like I say, traditional distributions are too slow. But they're not if it's a rolling release. And in the case of OpenSUSE with Tumbleweed, we have a rolling release now that isn't just some nice fancy dev branch which anybody can go on and play, but is actually usable for real work. It gets tested and only gets updated when the thing has been tested. And not just tested from a crazy code perspective, but actually automation tools, firing up VMs and on real hardware and running the thing like a real user will use it, so you know it installs right and you know the applications work right. And we do all of that at a pace where we can still deliver the upstream projects on top at the same pace those upstream projects work. KDE Plasma on the same day as release, GNOME 48 hours, that kind of thing. Maybe that's the better model to actually fix this app delivery. Maybe rolling releases are the way to actually go with all of this and just, reuse that knowledge we already have, reuse the tools we already have, reuse the infrastructure we already have in these communities, in these distributions, and just angle them way faster and way more, an awful lot faster than we've ever done in the past. And with that, I have time for questions. There's one guy here. Oh. There you go. No?
Whether keeping the base of the distribution static and keeping the applications updated only might be a good middle ground. For example, let's imagine using Ubuntu with a bunch of PPAs to update just the applications,
Yep.
and keeping a stable core so that we avoid big differences and big changes break the user's experience.
I really wish you'd been in my earlier talk in the distro dev room this morning, because, I basically discussed that. The problem I see with that idea is you end up with that same problem with the, that line. The line between the fast-moving containerized thing just becomes a line between the fast-moving applications and a static distro below. And you end up with compatibility and reliability problems with that line. In reality, if you want to do a rolling release properly, you have to be prepared to move everything. Your application is going to want to change dependencies right down the stack, have the tools to change everything right down the stack. And you have to find some way of preserving its stability, but you can do that.
So when we're talking about moving the line, why don't you just move the line down and include the distribution with the whole container? So actually it's really a virtual machine.
Well, then it's a virtual machine. Yeah, but then you end up with the issues of, nice big applications, lots of patching. I mean, you can, but it's not exactly a very efficient way of doing things. Yep. Yes.
Hi, Rich.
Hello.
So, in the past, we've had several libraries and things like that that end up with binary incompatible and mostly wire-related issues. Especially with one application using one version, not being able to load files or talk over the sockets with the other application. This is not something that containers are solving, it's just making it worse.
Nope.
Is it something we can fix? I'm not asking for the fix, I'm asking if we actually can fix it.
I don't think it's something we can fix. And I mean, basically that example you just gave and the example of non-open source software are two examples where I think this technology is awesome and should be used. Full stop, no caveats. As long as somebody takes care of all the responsibilities, that's where these actually solve a real problem. But saying this is a universal packaging tool for everything, I'm not convinced.
Here, I have a question. I don't see where the rolling release model, how the rolling release model could fix the test matrix problem. This is one of the problems we have in distributions, is that an application may rely on several libraries with different versions, and another application would rely on other versions. You can test everything. It increases complexity, and that's why this is all put in containers, because you have the control as an application developer on which versions are used. So I don't see how the rolling release solves the problem. Is it supposed to solve that problem? I don't know.
I think rolling releases go some way to solve that problem, because they so assuming your rolling release isn't just a collection of packages, but is a cohesive distribution that is built with, for example, dependency consistency, and you make sure it actually works. So like with OpenSUSE, OBS makes sure all the dependencies actually work together and the distribution is cohesive and works. There's not just random packages all over the place.
Yeah,
So in that case, your build process will find out where you have these multiple applications fighting for different libs, and then it's a case of either packaging or dealing with those upstreams. This might help. This was kind of the example he gave there. Of there are cases where these tools help, but I don't think they're universal.
Yeah, but for example, in the GNOME project, we had some problems with changes in the CSS management, in different GTK3 versions, and so several versions of GTK3 are not can't be installed in parallel. So one application may rely on an older version and a more recent on another version of GTK, and you have to choose which version you will install. So if you rely on a distribution model, you only have one of those versions installed, and I don't see how it can solve without containers.
I think the problem needs to be library maintainers need to stop actively supporting multiple versions that can't be installed in parallel. And that's, shifting the blame slightly, I know, but yeah. Hello.
So, on the first slide, I think, the first bullet point you wrote was that with Windows 3.1 and the shared library model system, all libraries dumped to the Windows system, one of the major problems with it was, and it really was, in fact, one of the major problems, the missing backboard compatibility of the ABIs. But the idea of that concept, even back then, was that you have backboard compatibility as long as the DLL name stays the same. So if you just use the newest DLL with the same name, or in Linux you use the newest shared object with the same SO name, it should be ABI compatible.
Yep, should.
So, and as you said, things break, and we use this container stuff because we have ABI breakages, although there should be none. So how is defining a new standard base helping against the, in my opinion, real cause of the problem that we have applications relying on properties of the ABI that are not guaranteed and specified, or library writers unintentionally breaking their ABIs?
Well, my idea for the standard base would be when you had those ABI breaking changes, that would require a new standard base version. So at least you're tracking when those changes are, around. It's another dependency problem, I admit it, but we need to spend a bit of time thinking about this, and or the alternative is every single application developer using these tools has a lot more work to do. And I'm not sure either solution is wonderful, but I don't think people really realize how much extra work they're putting on their shoulders just throwing everything into these tools.
So do you have already a plan to go forward? Like, which of the suggestions that you proposed you think is the best way forward? Like, is OpenSUSE like trying to propose a new Linux standard base?
Well, this is the first I've said about it, so every distribution that starts talking to me, now they've seen this presentation. I mean, I'm not fussy. I mean, it needs as many from as many places. I wanted to start the conversation here first.
Guys, no more questions? Thank you.
Thank you. Thank you very much. Sorry.